Good afternoon, my YouTube viewers. It is Crystal here, and I wanted to make another video for you. This is a carryover from my last video. In my last video, I was talking about his gradient boosting classifier to solve Kaggle's competition question about banking. In this particular video, I'm going to be using the Extra Trees Classifier to solve the problem. And the reason why I'm using the Extra Trees Classifier is because the Extra Trees Classifier is different from the Hist Gradient Boosting Classifier. And because it's different, that's the reason why I wanted to show you. And the reason why is because you can solve a Kaggle competition problem using a number of models. So this is just the Extra Trees Classifier is just one of many models that you can use. So the Extra Trees Classifier is a tree-based classifier. And the thing about the Extra Trees Classifier is the fact that you do not need to standardize the data. And I think in my last video on the Hist Gradient Boosting Classifier, I'm not sure if I standardized the data, and perhaps I could get a better score if I standardize the data. So maybe that's something I can do when I finish this video, is go back to Hist Gradient Boosting Classifier, see if I standardized it, and if I didn't standardize it, go ahead and standardize it and see if that improves the score. But the Extra Trees Classifier, you don't need to standardize it because it is a tree-based algorithm. So now that I've explained that, what I'll do is I'll go ahead and go over the code, because that's what you want to see is the code. You can see that the public score I got was 96%, which isn't too bad. There were higher scores, but 96% isn't too bad. The problem statement is use banking data to make probability predictions. But whenever I was reading the data on this particular competition question, it didn't say too much. And because it didn't say too much, I'm not sure exactly what we were predicting on, because it didn't say what we were predicting on in the data. So that's a problem with the documentation of the data, and that's one thing that I would like to point out, that maybe when Kaggle is presenting these competition questions, that they do a better job of saying what it is we're actually predicting. That would be a really good idea. So after we've defined our problem statement, what we want to do is we want to import the libraries that we're going to use to make this prediction. So we're going to import NumPy as NP, which is a numeric library that creates NumPy arrays. We're going to import Pandas as PD, which is a data processing library that creates data frames in series. We're going to import OS, which goes into the operating system. We're going to import scipy.stats .ks_2SAMP. This is a non-parametric test, and what this does is test to see if any of the features are not from the same distribution. And if the features are not from the same distribution, then you would just delete that feature because it would interfere with your reading. But you'll be pleased to know that there were not any features that were not from the same distribution when I conducted this test. The only feature was ID, and it was okay to delete that column from the train and the test set. And the reason why that is because Pandas automatically indexes every row. And then after we've imported SciPy, we're going to import sklearn, and sklearn provides the machine learning functionality. And then after we imported sklearn, we're going to import matplotlib.pyplot.splt, which is a visualization library, and Seaborn as SNS, which is also a visualization library. And now what we're going to do is we're going to use OS to retrieve the files. And the 3 files that we retrieve are CSV files, being train, test, and sample submission. And they have CSV on the end of them. And after we have used OS to retrieve the files, we're going to use pandas to read the files. And we're going to read the files and create data frames and call them train, test, and submission. So what we want to do is we want to set the program up to where you can view all of the columns. So in order to view all of the columns, you say PD, that's for pandas, dot set option, brackets, display dot max columns, comma, none. And what that does is that sets up the program or the Jupyter Notebook so you can view all of the columns. So now this is our train data frame that we have created, and it's got a Y on the end of it. And so I'm not sure exactly what the Y is for. I'm not sure if it's to do with giving somebody a loan or somebody defaulting on a loan or something like that, because as I said, Kaggle was not very good at explaining the data sets. And I think that Kaggle should have done a more comprehensive job of explaining the data sets so we would actually know what it is that we're making predictions on. And then so we check train info, and you see you've got integer features and object features. So at some point in the program, what we're going to do is we're going to encode the object features to make them numeric. But for the time being, we're going to leave the object features where they are. Okay, so now what we're going to do is we're going to get the unique values from all of the object features by using a for loop, for call in train, if train call dot dtype equals object, print call train call unique. And so these are all of the unique categories in the column in train that is a dtype object. We check to see if we have any null values, and we don't have any null values. This is our test data frame. The only difference between the train data frame and the test data frame is the test data frame does not have a target, and that is what we are going to be predicting on. We check for null values. We don't have any null values. And then so what we did is we used the same methodology that we had used with the train data set, and we got the unique categories from each object column in the test data frame. And so you can see what the unique categories are. Okay, so now it's submission. So submission is ID Y, and the Y is 0.5. So that's telling you that you're going to be predicting on a probability. So now we're conducting a Kolmogorov-Smirnov test, and that's a non-parametric test. And what that does is that tests to see if the columns are from the same distribution, and so stat, say for call in test, stat, comma, PV equals KS underscore 2samp, brackets, train call, comma, test call. Okay, so if PV is less than 0.05, you're going to add the column, the name of the column, to delete underscore calls variable, which we have defined previously to be a blank list. But you're going to put the name of the column into the list, and you're going to print, and then when you've gone through all of the columns, you're going to print the columns that have been added to the list. These columns will then be deleted from the trained data frame and the test data frame. And then you will check your shape. So you can see that the only column that was not from the same distribution in this test was ID. So we deleted the ID column. And as I stated, because Pandas automatically indexes each row of the data frame, it doesn't matter whether it's deleted or not. And so you can see the shape is 17 columns and 16 columns, so that's one less than what you previously had. So now what we're going to do is we're going to analyze the target. And when we analyze the target, you can see that you have a lot less ones than you have zeros. So that means it's a class imbalance. So that's a good thing, because the thing is that when you have a class imbalance, what you need to do is you need to balance it. But the great thing about a tree-based model is when you have a tree-based model, then it works differently than other models. So you don't need to standardize a tree-based model, and it just goes into the tree, and that's part of the mechanism for the training process. And now we're going to analyze the job. So you can see the highest job is a technician, the second highest job is a blue collar, and the lowest job is unemployed. So you can see the status of, the value counts of each job. And so we see a management is a lot less than a technician and a blue collar, and entrepreneur is less than management. So now we're going to analyze the marital status by making a pie chart. So you can see 64.1% are married, 9.9% are divorced, and 26% is single. And then we're going to do a pie chart of the education level. So 53.6% is secondary, 30.3% is primary, 13.3% is tertiary, and 2.8% is unknown. And then now we're going to analyze the default. So you can see that you have a lot more no's than you do yeses. And I'm assuming that they're talking about defaulting on a loan. And so a small number of people have defaulted on loans. And now we're going to look at the housing. And you can say more people don't have housing than do. But it's not a huge class imbalance, but it is a small class imbalance. Now we're going to analyze loans. So you can see most people haven't got a loan, but a few people did get a loan. And now we're going to analyze contacts. So 64.9% want to be contacted on a mobile phone, 4.2% want to be contacted on a telephone, and 30.9% is unknown. Now I ask about the month. So you can see I'm assuming that this is something to do with the banking transaction. So August has the highest number of transactions, and December has the lowest number of transactions. So now we're going to do a pie chart on the P outcome, and I don't know what the P outcome is, because as I said, they didn't really give a lot of information about the data frame. It would have been nice if they had given information about the data frame, like to say which each column was used for. That would have been really good. But 89.7% is unknown, 2.0% is success, 2.4% is failure, and 6.0% is other. So now what I did was I used seedborn to create a heat map of all of the numeric columns of data, the numeric features. And as you can see, that on these numeric features, they were not very highly correlated. And now what we're going to do is we're going to encode the columns. We're going to use sklearn's ordinal encoder to do that. And then so the train column is going to be fit transformed, and the test column is going to be transformed. So now we check our train, the information about the data frame again, and you can see that there's no more object data columns. It's all either integer or float. So what the ordinal encoder did was it took the categories and it converted those categories into a number. And you can check the test data frame, and you can see that that's all numeric columns as well. So now we're going to define our dependent and independent variables. Y equals train pop Y. That means Y is going to be popped out of the train data frame. X equals train. X test equals test. So now what we're going to do is we're going to split the data set up into, we're going to X and Y variables into training and validating data sets. And then we're going to define our model, which is an extra trees classifier with estimators equals 1000, class weight equals balanced, random state equals 42. And then we're going to fit X train, Y train. We're going to get the score, and the score is 100%. Y-pred is a prediction equals model predict xval. So you're predicting on the validation set. So you've got some ones and zeros. And then we check our accuracy. Your accuracy is 92.8%. So this is the great thing about these tree-based models, is with the tree-based models that what you can do is you can define the feature importances. And so that's what we're doing. We're defining the feature importances. So model feature importances gives you the number of the importances. And now we're going to analyze the feature importances. So importances equals model.feature importances. Feature names equals xtrain.columns.toList. Tree importances equals pd.series brackets importances comma index equals feature names. Trees importances plot.bar h. Title is feature importances, and PLT type layout. So you can see what the feature importances is. It looks, according to the feature importances, it looks like duration had the highest importance, and the rest of them, the importances were a lot less than the duration. So now we're going to predict on the test set, and what we're doing in this instance is we're predicting on probabilities. So pred equals model.predict proba brackets x test, and then we print pred square brackets colon comma 1 square brackets. And so what you're doing is predicting on the probability that it will be a 1. And then we prepare our submission. Submission y equals pred square brackets colon comma 1 square brackets. Submission.toCSV equals brackets submission.csv comma index equals false. Submission equals pd.read CSV, submission CSV, and submission. And this is what I submitted to Kaggle. And Kaggle used the, I think, ROC-AUC method to actually score the predictions. And I looked on the sklearn website, and on the sklearn website, I didn't actually see an ROC-AUC model that you could use. So I couldn't use that. But that is the scoring mechanism that Kaggle used on this. And then so when I submitted my work, it was 96%, which was good. It wasn't the best, but it was good. So that's it for this particular video. I mean, we reviewed the code for what I did with Kaggle's Playground Exercise Season 5, Episode 8. So I hope you liked the video and you found it informative. If you like my video, please like and subscribe. And I'll be making another video for you about this competition question very soon.